Hi, everyone. Thanks for joining this session. Today, I'm going to talk about Spring Cloud Gateway, in particular, how to build an API gateway for your microservice architecture and how to use it to implement cross-cutting concerns like security and resilience. I'm Thomas Vitale. I work as a senior software engineer at Systematic, a Danish software company. I'm really passionate about Spring, cloud native technologies, the DevOps culture, and application security. And I'm the author of Cloud Native Spring in Action, that is right now available in early access through Manning. Let's get started. The API gateway. Before going to talk about the specific technology, let's analyze the problem that we want to solve. So, which are the requirements? Let's look at some scenarios. For example, you have in your system different clients that need to talk with different APIs. Maybe you have web applications, mobile applications, you might have IoT devices. In that case, you might want to handle in a different way requests coming from each of these different client type. This pattern is also called sometimes backend for frontend. Or maybe you are going to move your monolith to a microservice-based architecture. So you want to start extracting some functionality from the monolith to turn it into some standalone independently deployable application. And to do that, you don't want to affect the clients. You want to maintain the same API. You want to keep a consistent experience to all the clients. And in that case, if you use an API gateway, then you can shield the clients from any change happening behind the scenes. Or maybe you want to have your clients not aware of all the different services that are part of your system. In a microservice architecture, there might be really a lot of different microservices. So it would be really hard for a client having to know everything about each single API and when it changes, like how to make sure that all the clients will switch to use the new API. With an API gateway, you can solve that problem. And then since an API gateway is at the edge of your system, is the entry point to your system, it's really a good place to implement cross-cutting concerns that we usually have in distributed systems, like, for example, authenticating the users. So it's the first service that a client or user will interact with. So it's a good place to do authentication, authorization, to handle resilience concerns. And this brings us to Spring Cloud Gateway. That is a product in the Spring ecosystem that not only gives you the chance to implement an API gateway, but also integrates in a very straightforward way with all the other projects like Spring Boot, like Spring Web Flux, and Spring Security. So it's really, really simple and effective using this Spring Cloud Gateway library to define your edge service, your API gateway. Let's consider an architecture like this one. We have a set of microservices in the backend that might interact with other services like databases or maybe even third-party services. And then the entry point to the system is an edge service, an API gateway that not only like takes care of handling all the requests coming from users, coming from clients, but also to apply cross-cutting concerns like security, like rate limiting, circuit breakers, and all those nice things that we like in a microservice architecture and more generally in a distributed system. Today, as part of a demo, I will focus on the edge service, of course, and we're going to use Spring Cloud Gateway to implement that, and also on book service. So we're going to look at one service downstream, but then the same behavior is applicable to all other backend services. So Spring Cloud Gateway. This project is really focused on building performant API gateways, performant edge services. Since it's the entry point to your system, you don't want to have a bottleneck. You want something that is really performant. And that's why Spring Cloud Gateway is built on the reactive stack in Spring. So it's based on Spring Webflux and Project Reactor, exactly because we want to maximize scalability and resilience. And that's what Reactive can help us with. Reactive Spring, let's talk about why we need that. So why we want to go reactive for the edge service, for this API gateway. If we look at how a traditional application works using the imperative model, so if you think about a Spring Boot application using Tomcat, for example, so based on the servlet API, we use a thread per request model. It means that for each HTTP request that comes into our system, we allocate a thread exclusively to that request. And this is fine. So for each request, we have a thread handling the request. But if our application does, for example, database calls or calls to other services, then we might incur into issues because the thread will just stay idle, waiting for a response to come. So it will send, for example, a database call, and then it will just sit there waiting. So we are not using resources efficiently. And that's one issue. The other issue is that the concurrency degree of our application is actually tied to the number of threads. So if you want to support more users, more clients calling your API, you need to put more resources to your system because threads will need more computational resources. So instead of doing that, we go reactive, and the reactive model is based on an event loop. In this model, we don't allocate per each request a thread, but the handling happens asynchronously and in a non-blocking way. So a thread will start handling a request, and if there is an IO call, for example, to a database or to a backend service, then the thread will not stay there waiting. Will register a callback and then move on doing something else. So it means that with fewer threads, we can handle more requests than in an imperative application based on the thread per request model. And that's why we want to use this for an API gateway. The Reactive Spring stack is built on top of Project Reactor, which is an implementation of the Reactive Stream specification. And most of the projects in Spring provide both an imperative and a reactive option. So from the web point of view, we have Spring MVC for a servlet-based application and Spring Webflux for reactive applications. And then we have all other projects in supporting both type of applications. So today, for example, we're going to use Spring Security Reactive because we're going to build a reactive application, and we're going to use Spring Data Redis Reactive. The nice thing about the Spring Reactive stack is that you don't need to be concerned with the underlying implementation. So how this asynchronous handling happens, callbacks, and everything is handled by the framework. So you can use the same familiar interfaces that Spring Boot has always offered to us as developers to make us productive in a very simple way. And this brings us to Spring Cloud Gateway. So on top of the reactive stack, Spring Cloud Gateway provides out of the box all those features that we really like in an API gateway. Starting from routing request, of course. That's the basic feature. Let's have a look at the architecture. From a client, we receive a request, and Spring Cloud Gateway, first of all, tries to map that request to some predicates. So we might check for the path. For example, if it's /books, then we send the request to the book service. If it's /orders, then we send it to the order service, for example. After matching against predicates, we can run the request through some filters. We can do that before sending the request downstream and after receiving a response. So before sending the response back to the client, and that's really convenient. And as part of this filtering mechanism, we can do any kind of manipulation, not only on the HTTP request headers, but also on the body itself. At this point, let's have a look at the first basic cloud gateway application. We can start by generating a new project from start.spring.io. I'm going to use Gradle, the latest Spring Boot version available. This will be an Edge service application. And really, the only dependency that you need is the Spring Cloud Gateway dependency. On top of that, we're going to use a few more dependencies. So we're going to use Spring Security, and we're going to use the OAuth2 client provided by Spring Security. Yes, and we're gonna use also Redis, and in a second I'm gonna explain why. And that's it. I have already opened the project in IntelliJ, so let's have a look. So Edge Service is a very standard Spring Boot application. Let me fix the dependencies here. So we have the main class, standard Spring Boot application, and the only dependency that I'm going to use for now is the Spring Cloud Starter Gateway. We can ignore all the others. I'll keep enable the Spring Boot actuator because I'd like to get some metrics in order to investigate how the application is doing. And I can show you I have, so as a dependency, I have the Spring Boot actuator dependency. And then since I want to expose metrics through Prometheus, I also added this micrometer registry Prometheus dependency. Then on my machine, I have a Prometheus instance running that is calling the metrics endpoint from this application. And I have Grafana, which is using those metrics to visualize the data in a nice format. So I have a Spring Boot dashboard, and I can check how the Edge service is doing, which is pretty cool. And then at the backend or downstream, so this is the API gateway. So it's the API, the gateway to what? To book service. Book service is a simple reactive Spring application. So you can see I have, once again, the Spring Boot actuator, and then Spring Web Flux, because it's a reactive web application. And the implementation is really straightforward. We have a book controller, which exposes two endpoints under /books, one for retrieving some books and one for creating books that is not implemented. We're not going to use it. And the book object is also quite simple. We have a name field. I'm using Lombok for generating some boilerplate code here. This is not Spring. Yes, so at this point, the first thing we want to do, maybe I can demonstrate how the book service application works. It's running on port 9001, so I can fetch the list of books. And, oh yeah, it's not running. So let's start the application. Yes. And now it should run. Perfect. So the first thing I want to do is having the Edge service intercepting this request and forwarding request for getting books to book service. So I'm gonna switch branch now. And in the application property file, we can define a route. So you have two possibilities here. You can use the Java DSL, so have this route configuration in your Java class or in an application property file. I prefer this approach because I think it's the more convenient one if you need to update this configuration in production. So you can use something like Spring Cloud config or the config maps provided by Kubernetes. So it's easier to update this configuration at runtime. And what I'm doing here is defining a new route for Spring Cloud Gateway. I called it book route. And what it does is intercepts all requests to the path /books, whatever that is, any kind of request, get, post, delete, and sends those requests to the URL localhost 9001 /books, which is where book service is listening on locally. I also define this environment variable here because maybe in Docker or Kubernetes, I want to override this value, of course. It's just to make that easier. Once I have this route configured, I can do the same call that I've just did, but not directly to book service, but through the edge service. So let's start the application. So now the edge service is exposed through port 9000. So I can do a get request on port 9000 /books, which is intercepted by this predicate here. And here it is. I got the response back. So far, nothing really exciting. I mean, it's just a proxy, right? But Spring Cloud Gateway does a lot more than that. This is the predicate functionality, but the real power of Spring Cloud Gateway is the filters. So let's have a look at that. The first filter I'd like to talk about is the retry filter. So if the book service is momentarily not available for any reason, instead of failing the request, I might configure the Spring Cloud Gateway so that the request is retried a couple of times, maybe, just in case. Hopefully, the book service application is again available in really a few instances. When we do a retry, it's important to not keep retrying the request continuously, but we want to leave some space, some delay between each request, increasing delays, so to not attack ourselves with a DOS attack, right? So after the first request, we can adopt what is called a backup strategy, so that each retry attempt is delayed more than the previous one. In the picture here, you can see that the first request coming through the edge service fails with a 503 error, service unavailable. We try again and it fails. We wait a bit more, we try again, and finally succeeds. We can do this by configuring a filter in Spring Cloud Gateway, which provides already a retry logic to do that. So let's go back here. And once again, the whole configuration will be in this application YAML file. So just to review, we have a routes section where we have one route and one predicate. We could also start adding filters to the specific route, but I like having the retry mechanism applied to all routes and specifically to all GET requests. So I can define it in the default filter section. So it's a filter that is always executed, so independently from the route. And here the filter is called retry, and I can configure how it should behave. So in this case, I configure 3 retries only for the GET request, because GET requests are idempotent. So I'm sure that retrying the request will not cause any trouble. But if I retry a post request, then I might produce some inconsistent state in the system. So we need to be careful there. In particular, I want to retry only if it's a server error, not a client error. So this is to catch all the 500 errors. But if I receive a 404, for example, then I don't want to retry, because the server is actually responding correctly. And also, I can filter even more by saying for all 500 errors, but only if there is either an IO exception or a timeout exception. And finally, I define the backup strategy here. So I start by waiting 50 milliseconds before the first retry attempt, and then I multiply the the factor number. In this case is 2, for the first backoff, so that every time I wait a bit more before retrying, up to 3 attempts. If that fails, then I just get an error. So we can test that out. So what I'm going to do now is stopping the book service application. So the response will be an error. And then from here, I'm going to run the request again. And Spring Cloud Gateway will try 3 times to call book service, and finally fail because there's no reply. But of course, this is useful when, for example, the service downstream is momentarily unavailable because maybe it's just been restarted, or maybe it's particularly overloaded, so it cannot take more requests. And that we can make that kind of integration more resilient by using retries. But of course, if the book service is really down and will not go back up and running in a few instances, then the retry pattern will not help us too much. And in that case, we can try something else. So the circuit breaker is a pattern that helps us in that situation where the service downstream is not responding for a long period of time. So instead of keep retrying the request, the circuit breaker will just interrupt the communication with the service downstream for a while, and then try again a bit later to see if it's back up and running. If not, then it interrupts the communication again. And it works as a state machine. So the default state is the closed state. That is the normal behavior of the system. It means the circuit is closed, so edge service can send requests to book service. But if in a period of time, if we have a lot of error coming from book service, so if that forwarding triggers a lot of errors up to a certain threshold, then the circuit breaker trips and becomes open. When it's open, we don't even try to send a request to book service. So the request is directly rejected. Then after a while, it switches to the half open state. That is sort of investigation state. So the circuit breaker will allow to send a few requests to the service downstream. If they're successful, then the circuit becomes closed again. Otherwise, goes back to be open. But let's have a look at an example so that we can understand better how it works. So I'll switch branch again. So first, I'm gonna start book service because I want to show you how it works in a normal state. So let's do that. And then in Edge service, in order to support the circuit breaker, we have to provide the dependency, which is the Spring Cloud Starter Circuit Breaker Reactor Resilience for J dependency. Really long name. So it's basically the Spring Cloud Circuit Breaker project, which uses Resilience for J as the implementation. You might be familiar with something like Hystrix that is now in maintenance mode, so it's not maintained, supported anymore in Spring Cloud. So Resilience for J is the current library used to implement different resilience patterns, including the circuit breaker, and also provides both an imperative and a reactive implementation. So in this case, we're using a reactive implementation. After providing this dependency, we can once again configure the circuit breaker in the property file, and we can do that through a filter. So in this case, so before I used a default filter, here I want to use a filter specific to the book route. So the name of the filter is circuit breaker. I can give it a name, for example, book circuit breaker. And also, if I want to, I can define a fallback. So this fallback means that when the circuit is open, instead of returning an error, I might define some fallback behavior directly in Spring Cloud Gateway. So in the example of the book service, maybe I can return an empty list of books instead of throwing an error. Or if I cache the previous result, I can return the previous result. So it might not be up to date, but still it's better than failing. So the really important aspect here is that we want to ensure that all our applications keep their availability state. If we cannot guarantee that, at least we should guarantee a graceful degradation of functionality. We don't want to fail hard. So in this case, we want to have a fallback without returning some errors to the user. Maybe with a message informing them that the result might not be up to date, but maybe try again later. And then we need to configure how we want the circuit breaker to behave. And we can do that in Java here. I created a configuration class, and I'm using the customizer object for the resilience for J circuit breaker. The first thing I do here is defining the sliding window size. So this is the number of requests that the circuit breaker will inspect in order to make a decision about whether the circuit should be open or closed. So in this window of 20 requests, if more than 50% fail, then the circuit goes to be open. After 30 seconds, trips to an half open state. And when it's in a half open state, I allow 5 requests to go through. Among those 5 requests, if at least 50% of them are failing, then the circuit goes back to the open state. Otherwise, goes to the closed state. So everything can continue as usual. And then I also configured a time limiter, which is another pattern implemented by Resilience for J, so that for each request, I don't wait more than 1 second in this case. Yeah. So these values now are hard-coded, but of course it would be better to provide them through configuration properties. You can either define your own properties or bring in a dependency provided by Resilience4j and its integration with Spring Boot, so that actually you have some properties that you can use to pass values here. So if you want to customize it further in production or depending on the environment, you can do that. But for simplicity here, I use the Java configuration and hard-coded values. Yes, that's it about the circuit breaker. So I'll start the application now. And I want to point out also that I'm using a second dependency. So one is the main Spring Cloud circuit breaker dependency with the reactive version of Resilience4j, but I'm also using the Resilience4j micrometer library. So this one will extend the Spring Boot actuator behavior so that among the metrics, I also have some metrics specific to the circuit breaker. And in Grafana, I actually have a dashboard for that I'm going to show you now. So for basic investigations, I have this dashboard, which presents a lot of different data regarding Spring Boot applications like CPU usage, memory usage, JVM, number of threads, and I have the possibility to check both Edge service and book service. But I also have a dashboard for Resilience4j. Here it is. So Edge service is the application with circuit breakers, but the same library, you can use it also in any Spring Boot application. So it's not something implemented or available only in Spring Cloud Gateway. The only difference is that in Spring Cloud Gateway, you have a filter built in to use a circuit breaker, but the same configuration you can apply to any kind of Spring Boot application, which is really nice. And so the application is running, so we're gonna see the values there in a second. Let's make some requests. And is book service running? Yes. Yes, I think I have to increase the timeout here because my machine is really overloaded. We might have some data. Yes. So here you can monitor the 3 states of each circuit breaker. And in a second, I should also be able to select the name of the circuit breaker. There's a bit of delay when Prometheus scrapes the application. But here you can monitor when how many circuit breakers are in the closed state, open state, and half open. Yes, now it went through. So actually, we just seen the circuit breaker working. Well, not really. I guess it was the time limiter. But since my machine is really overloading, it takes more than a second to send the request because of all the streaming software that is running. And you saw that I didn't get any exception. I actually got a fallback result. And where is that defined? I can show you. In the application YAML file, I define here a forward to a / book fallback endpoint in case the request doesn't go through. And that applies not only if the circuit breaker is open, but also if the timeout expires, like it happened now, and it didn't get a response back. And this endpoint, you can define it as you normally do in a Spring application. So you can use either a REST controller or router functions. In this case, I used router function here. So in a configuration class, I define two routes, one for get request to /book fallback and one to post request to /book fallback. And for the get request, I returns an empty result. And you saw earlier that I got an empty response back. That was an empty list. Instead, for a post request, I don't have a fallback, so I just throw a 503 error in a very simple way, but I might do something better here to improve the user experience. So now we can try shutting down book service and see what happens. So I'm going to use a tool. It's called Apache Benchmark to send maybe 100 requests with maybe 2 at a time, concurrency 2, or yeah, let's do 5 to the edge service. Let's see what happens. And then we're gonna get more data here as well. Yes, so since book service is not available, the circuit breaker after 20 requests, that was the sliding window that we defined here. So after 20 requests, open the circuit, and you can see that it's in the open state. Yes. Now for 30 seconds, the circuit will remain open, and then it will transition to a half open state. So first of all, let's start book service again, and then we see what happens after the circuit breaker becomes half open, and we can monitor the status here. So while waiting for the 30 seconds to pass, I want to show you a third dashboard that I have here, which is also useful. And this time is specific to Spring Cloud Gateway. It's used to monitor routes. So I select the application here, and then a route ID that in this case is book route, and select the last 15 minutes. So I can see what happens in my edge service. So this is the time where I didn't make any request, but you can see the number of successful requests and the number of unsuccessful requests and some more details. All this information are provided by the Spring Boot actuator. So we can even check that if we go localhost on port 9000, you can see on /actuator/Prometheus, which is the endpoint created by the Prometheus server. You can see all the different metrics that the application is exporting by default, plus the ones from Resilience4j, since we added that extra dependency. Let's go back to the Resilience4j dashboard. So now I'm gonna send one more request. And the circuit should reset. At some point. Yes, now it's half open. In this state, I can run 5 requests according to my configuration. After that, it will go back to be open or closed depending on the outcome. Since book service is running, I can run a few requests that will be successful. Because yeah, there was more than 5, and the circuit will go back to be closed. So far, I talked about how to make resilient the integration point between the API gateway and all the services downstream. But sometimes you might want to have also some behavior applied at the very entry point. So I'm talking about rate limiters. So maybe you don't have a lot of resources, so you want to prevent DOS attacks, or if you're starting a special offer on your online application for e-commerce, maybe you want to apply a rate limiter so that you don't get too many requests or more requests than your applications can actually handle. Or maybe you want to distinguish between different categories of user. So if you have subscriptions to use your APIs like basic, premium, or plus, then you can use a rate limiter so that for each type of user, they can only send a certain number of requests within a specific period. And about rate limiters, I really recommend reading the article I linked here from Stripe about how to use rate limiters in the most effective way. Once again, Spring Cloud Gateway provides that implementation. It's using the, let's see first, the dependency, because in order to keep track of how many requests each user is sending, we need to save the state. And we can't save the state inside the application because that would make the application stateful, and we don't like that, especially in a cloud environment. We prefer stateless applications. So to have a distributed state available across different instances of the edge service, we can use Redis, as I mentioned at the beginning. So in this dependency list, I also enable Spring Data Redis Reactive. And I don't have to provide a lot of configuration, just how to contact the Redis container that I have running on my machine, localhost port 6379, and then some timeout here. And then, of course, there's a filter for the rate limiter as well. So all these behaviors are usually available through filters. And just like for the retry filter, I want the rate limiter to be a default filter so that it's always applied. And using the Redis implementation, I can rely on a token bucket algorithm so that each user is associated with a bucket that contains at most 20 tokens. And each second, 10 tokens more are dipped into the bucket. So if we reach the maximum, then we have to wait the next second in order to get more tokens and actually send a request. So each request requires a token to be performed. You probably saw earlier that when I send a request, I get back these special headers in the HTTP response. This is the default behavior of the rate limiter implementation, but you can also remove them. And I can see that in this case, 20 is the maximum capacity. I used one token for one request, so I have 19 remaining. And once again, if I use Apache benchmark, I can send 40 requests with a concurrency of 20. When I apply the rate limiter, the request, if I don't have a token available, then it's rejected directly. So it doesn't go through retry, circuit breakers, nothing there. It's rejected right away. So you can see here that 40 requests are completed, but 20 failed because I used the first 20 tokens, and then since the request was done in like 100 milliseconds, then I didn't get the new group of tokens to use. So after 20, everything else got rejected. In my dashboard, I can monitor that once again in my gateway dashboard for the book route. And I can keep track of all the unsuccessful requests and why. So you can see this too many request error. That's what happens when I don't have tokens left. So at this point, we made this our system more resilient with all these patterns, and we have an API gateway that acts as an interface between clients and users and the downstream services. It's time to implement some authentication. Since it's the entry point of the system, we also want to take care of that, of course. And we can do three things here. First of all, we need some session management functionality, because just like for rate limiters, we want to keep track of the user that are currently logged in. So if we use, for example, OAuth 2 and OpenID, then I need to store safely and accessible from all the edge service instances the tokens. So then I can define the OAuth 2 client within Spring Cloud Gateway so that the authentication is done at the edge, and I don't need to worry about that in all the other microservices of my system. And then for all the other microservices, I can just configure them to be resource servers. So they will just be interested in getting a token. They verify the token. If it's valid, then they process the request, but they are not concerned with the authentication part. So first I need to start I'm using locally a Keycloak container, which is an authentication provider supporting standards like OAuth 2 and OpenID. And then I switch branch again, and we're gonna see how to accomplish this. So I want to start by enabling the dependency. So the build.gradle, I need the Spring security dependency, and in particular the OAuth 2 client dependency. I already have Redis, so I can use Redis for sessions, and I can use Spring Session Data Redis so that automatically every session object is actually stored in retrieved from Redis, which is very convenient. So let's go to our good old configuration file. We have one first filter to enable, that is save session. This filter makes sure that we save the session before forwarding the request to a downstream service. So we make sure that we save in Redis the tokens. Then we have yes, we have another filter. It's called token relay. So what happens is that in Spring Cloud Gateway, we authenticate the user. So we get from Keycloak in this case, but it can be any authentication manager, we get back an access token. And then we forward that access token to the service downstream automatically. I don't have to do anything. I just need to enable the filter so that book service will receive the token. I configure the session to actually use Redis. And then I need to configure the integration with Keycloak. And I can use the standard Spring Security OAuth 2 project. So what I'm doing here is not specific to Keycloak, but it can be applied to any authentication provider. So the same code will be valid for login with Google, with GitHub, with Okta, which is really nice. So in here, I define how to contact the authentication provider, like the name and the secret. Of course, in production, you don't want to do this. If you're using Kubernetes, use a secret, or maybe use a vault. Spring has also a nice integration library with HashiCorp's vault. And then I point to where Keycloak is running. So to sum up, what I did was configuring the web session to use Redis. Then I configure the OAuth2 client to talk with an authentication provider. And finally, I enable the filter to send the token to the services downstream. And the services downstream, like book service, only need one thing, actually two. One is the dependency on the OAuth2 resource server project. And the other thing is the URL to contact the authentication provider. This is necessary because book service needs to validate the token with the keycloak. Then, so Spring Security by default protects all the endpoints. Since I'm running locally a Prometheus server and Grafana, I don't want the monitoring endpoints to be protected behind authentication. So for this specific demo, I added some more configuration here in order to allow requests to any endpoint from Spring Boot actuator. And then I added a logout handler, which lets me logging out not only from the Spring application, but also from the authentication provider using the OIDC standard. So I think that we are ready to test it out. Yes, let's start the application. So for the front end, in this example, I'm using an Angular application. And something to notice is that I'm not using the tokens in the browser. So Angular doesn't know about Keycloak or about OAuth, but I have a traditional session-based communication between the Angular application in the browser and Spring Cloud Gateway. So the whole authentication flow is initiated by Spring Cloud Gateway. I prefer doing it this way because I want to keep the tokens in a safe place, and I cannot do that in the browser. Of course, there are different techniques when you don't have a backend service, so to initiate an OAuth flow from the browser. But if you have the possibility, I recommend doing it in the backend. It's even easier because you just exchange maybe a session cookie between browser and the backend. And we know how to do that because we've been doing that for years. Yes, so for this example, I'm not going to use the REST API, but let's have a look at the Angular application, which is super simple. So I'm not logged in yet, so I'm redirected to this page that is provided by Keycloak, my authentication provider. So I can log in now. And now I'm inside the application. So the only thing that I can do in this application is getting a list of books. Let's see if I did everything correctly. I did. Yes, I got the list of books. So I'm logged in through Spring Cloud Gateway, which redirects me to the authentication provider. Spring Cloud Gateway manages these tokens using Redis for the distributed session management. And then the access token is sent to book service. And I can also show you that that is actually what is happening because book service also has a security configuration. So you can see that all endpoints except the monitoring endpoints are protected. It means that if I want to get books, I need to be authenticated. And here I can see in this log message that there actually was books browsed by Sheldon. I can intercept the token in the controller. I use the authentication principal annotation to inject automatically the token. And then I can just inspect the attributes, which is really convenient. Then if I need more data, I can use this token to talk with Keycloak and get maybe more information about the user, checking the ID endpoint. So let's go back to this picture. To sum up, what we've done so far is implementing an API gateway so that we can shield all the microservices inside our system from the outside. We configure routing, so we can maintain an API to the clients without being affected by the changes done inside the system. And we also implemented several cross-cutting concerns. So we made resilient the communication between edge service and the services downstream. So we used circuit breakers, we used rate limiters, retries, and timeouts. And then, since this is the entry point of the system, the access point, we also implemented rate limiters in order to protect our application from receiving too many requests, or maybe because we have a subscription model so that users can only perform a certain number of requests. And then we implemented an authentication and authorization flow using Spring Security Auth support. And we used, in this case, Keycloak as the authentication server, but it can be any kind of standard Auth2 or OpenID provider. So with this, aspect, I'll end my presentation. I hope you enjoyed it, that it was useful. You can find more information about this topic, of course, in the Spring documentation, which is really well written. You can find a lot of information about all the filters, all the different integrations, and all the different functionality that you can implement in Spring Cloud Gateway, also how to make it high available in a production environment. I also talk about this project in my book, Cloud Native Spring in Action. Actually, the chapter about Spring Cloud Gateway is about to be published. It's almost there. And for you today, I have a 40% discount code thanks to Manning. So you can use this code on the Manning website, not only for purchasing my book, but actually it's valid for all the products in the Manning catalog. So thanks, Manning. And that was it. So I wish you a really nice day. And for any question, or maybe if you want to reach out to ask some information, you can find me on my website, thomasvitale.com, or on Twitter at VitaleThomas. So feel free to reach out. I'm always eager to talk about cloud native technologies and Spring and Kubernetes. So I'd be happy. Yes. So thanks for joining, and see you soon.